now you should be ready with pen, paper, and calculator. So you can see here only one statement has been given, which is very simple one, that a rotating shaft, a steel shaft, having ultimate tensile strength as a 1200 megapascal, that is Newton per millimeter square, and diagram of that shaft has given, and it should support, that is must support a load, that is F is equal to 2 kilonewton with reliability of 99%. And they are expecting actually that calculate SE, that is endurance limit for this case. As we know that endurance limit, while we are going to calculate the endurance limit, we are going to take into account various factors. And that various factors which we are going to consider are Ka, Kb, Kc. As per the requirement, we are going to use all that factors. Last lecture, we have seen what that endurance limit is, how that Moore has converted, or that Moore has taken that endurance limit into account, and how we can calculate the value of that Moore's that endurance limit. Later on, we have seen what are the actual facts rather than the experimentation which we have done. From that experimentation, how we are going to get data and how we can interpret that data for actual problems. So here it is also expected that we should able to interpret all that data, that is experimental data, SUT value, which we can get from the experimentation, and we should implement it to this problem which we have to solve. Okay. So all the dimensions are given for this shaft. Just we have to check or calculate what are the various stresses which are going to develop in this shaft. And we have to calculate value of endurance limit value, actual endurance limit value. Now the force which has given is 2 Newton. It is said in the statement that it should support to the 2 kilonewton force. Now, while we are going to say that it should support to the 2 kilonewton force, then one can ask that, sir, what is the amplitude of this force? So that we can calculate the maximum stress and minimum stress, and later on we can go on calculating the mean stress, average stress, and amplitude of that stress. All these calculations, while if that calculations are required, and how one can do all that calculation, because it is mentioned in the statement that force is not repetitive actually. It is 2 kilonewton only. But you can read the statement, a rotating steel shaft. That means the shaft is rotating, and vertically if you are going to apply this 2 kilonewton force, then in that shaft, as it is rotating, shaft is rotating, right? So while this shaft is going to rotate, at that time, this load as it is stationary, we can say that hello. So this load is not the load which is given in the statement, though it is not fluctuating, but as the shaft is going to rotate, that's why in every part of that shaft, this repetitive stresses will be getting induced. That is tensile and compressive. Now, while we are going to solve this problem, just you can see the dimensions of this rod. That is 20 millimeter diameter. One, and later on one step is produced here. which is having 15 millimeter diameter, and this fillet radius has been given of 2 millimeter radius, and this point F, we can say the point C where the force is applied, which is 130 millimeter from the support bearing A. Then the step which has produced is at 250 millimeter from support A, and the other end of shaft is total 400 millimeter. So length of the shaft is 400 millimeter. I'll copy this diagram as and when it is required, we'll paste it where the calculations are required. So first of all, we are going to say what is given in the problem. Now in the problem, ultimate tensile strength is given for the material, and that is equal to 1200 megapascal, that is the Newton per millimeter square. And reliability is given as a 99%. So when we are going to say this reliability as a 99%, we know that which factor has to be calculated from the reliability factor. Before going to calculate all that factors, first of all, we have to calculate what stresses will get induced in that. Because unless and until you are not knowing the stress, we cannot go for calculation of endurance stress, because this SUT is one type of stress. Then SE dash is again stress, that is endurance limit, and SE, which we are going to calculate, that is again stress. So as the load is given and we know the area, that's why we have to calculate the stress first. But for the calculating of stress, directly we cannot take this as a force which is acting as a 2 kilonewton, and resisting area is pi by 4 20 square, and here it is pi by 4 15 square, and this 2 kilonewton divided by pi by 4 is 15 square. That will be the stress which will get induced in this component. That is not the case, because stress is variable. That's why we have to calculate all the reactions first of all at point A and point B. Then bending stress which will get generated, that bending stress has to be calculated, because this is not what shear stress or tensile or compressive stress. It is a bending which is occurring in this shaft, where vertically in upward direction, if you are going to apply this external load 2 kilonewton, then the shaft is going to get bent. At point F, force is applied here, and due to which the shaft is going to get bent. So while bending is occurring, so that bending stress which is responsible to get the failure of this component or of this shaft. And as continuously you are going to apply this force, and this shaft is going to rotate, that's why every time this force is applied at new points, and these new points are going to undergo to the compressive, and lower side is going to undergo to the tensile. That's why it is repetitive, and completely repetitive it is again. Okay, that is reverse the stress. So first of all, we will calculate the bending moment. So bending moment at point B is equal to our combination all summation of all bending moments at point B is equal to 0. For the stability, we know that if the shaft is supported by means of bearing, it means that it is not moving in upward or downward direction. So the shaft diagram already which I have copied, I will paste here now. Now, as this shaft is not moving up and down, that's why it is well supported at point A and B. It is rotating, but bending is not responsible for rotating. That's why we have to calculate, or we have to take bending moment at point B equal to 0, summation of all bending moments. So how we can calculate this bending moment at point B? Now the force which is acting, we are going to consider that the reaction at point A, which is in vertically upward direction, okay, this, and the force, external force which has applied at point F, this force. So Now, if you want to calculate the bending moment, it will be definitely RA, where we are going to consider this RA here. So this RA multiplied by, here again capital, multiplied by its distance. So RA multiplied by 400 millimeter, because you are going to take moment at point B. So this RA, which is acting in downward direction, okay, we can consider it as anti-clockwise, and we'll consider it as anti-clockwise positive, whereas, once again, this is acting in upward direction actually, not in downward direction. So when the reaction which we are going to consider, it is in opposite direction. We'll consider this rather than this. So this is RA at point A. So while we are going to calculate the bending moment, this is going to create clockwise, okay, and definitely this externally applied force F, which we have mentioned as a 2 kilonewton, is acting in downward direction. So this RA multiplied by 400, here it is written, minus, because it is in opposite direction, okay, we are going to consider clockwise as a positive, anti-clockwise as a negative. So RA, we are going to consider that bending moment which is created by RA as a positive, and 2 into 10 raised to 3, because we are going to convert this kilonewton into Newton, multiplied by its distance. Now, while we are going to calculate its distance, 400 minus 130, how much it will be? Hello? Hello? Can anybody calculate this? Because these things, I will say, which are not correct answers. So you calculate it. What I should write here? Do you have a calculator with you right now? 400 minus 130. Can you करो the calculation? Students should do.
करेक्ट है
Correct,
सर
है?
270
Okay, 270. So what is the RA which you are going to get? Is 1350 Newton. Okay. Likewise, what we have to do is that you have to calculate RB. Okay, with this same diagram. Do your calculation and you give me answer. Do it fast. Have you got the answer? You do one thing, sir. Take photograph of that. Okay, no problem. We'll measure it. Hello. So what RA we have got? What is the value of RB? Who is
Yes, sir. 1350 Newton.
1350 Newton? Yes. So it is 1350 RA we have got. I was asking RB. So for that we'll take summation of all vertical forces equal to 0, and uh, this vertical forces we are going to consider as a positive. Okay. So vertical force which is acting at point A is in upward direction. Okay. Also vertical force which we are going to consider as a reaction at point B is in again upward direction. So this reaction which is in upward direction. Okay. So this RB now RA upward positive, RB upward positive, RA plus RB minus this 2 kilonewton is acting in downward direction. That's why 2 into 10 raised to 3. This much force is equal to 0 because this shaft is stable, that is not moving in up and down, rotating. Okay. So this equation, if you are going to solve, then you are going to get value of RB by putting value of RA here in the equation. You are going to get as a 650 Newton. Now RA we have calculated 1350, RB we have calculated 650 Newton. From this, we are going to move further. Once you have calculated this RA and RB, we can calculate bending moment. Now, as far as this diagram is considered, where bending moment will be maximum, where bending will occur, maximum bending will occur. Is it at point where the force is acting, or it will be at point A where the cross section is going to change, or it is in entire part of this B, A to B. Okay. Now this point D, D to B, this A, B, C, and D. Okay, where this maximum bending moment will occur. That definitely we are interested where the stress concentration is going to be more at this region. So we are going to calculate bending moment at that point where the stress is more concentrated. Okay. So at point D we have to concentrate and we have to calculate the bending moment. So we cannot just ignore point C because this C is the point where force is acting. So at point C also we'll calculate bending moment, as well as at point D also we'll calculate the bending moment, and whichever may be larger that we'll take for the calculation. Okay. So when we are going to calculate bending moment at C, it will be from one side we are going to go, and it will be RA multiplied by its distance 130 millimeter. The bending moment which we are going to calculate at point C is RA multiplied by 130 millimeter. So it is 1350, that is RA, multiplied by 130, that is distance, and this value which you are going to get will be in Newton millimeter. Okay. So this value which we are going to get is 175.5 into 10 raised to 3 Newton meter. That is the bending moment which is at point C. Whereas if we are going to calculate bending moment at point D, which is our point of interest, and we think that is important, and maybe this bending moment will be high at this point D. So it can be calculated as RA. From one side we are going to take that bending moment, RA multiplied by this distance, that is 250. Now what we have to do from this, while is it correct formally by means of which we can calculate this bending moment at point D? Hello? or it is not complete? How one can calculate bending moment at point D? कदम हा बेंडिंग मोमेंट काढायचा फॉर्म्युला बरोबर आहे का? हा Rohit, do you want to say something?
Sir, hello, sir.
हाँ जयदेव.
The force acting F, it should
Hmm.
also be considered.
Hmm. Hmm. So what will be the bending moment at point D?
RA into 250 minus
Minus
F into
F into
120.
120. Okay. So we calculate now F value is 2 into 10 raised to 3. I put that value 2 into 10 raised to 3. It is there, but the only thing is that I have put equal sign over there. All right.
Yes, sir.
Instead of that, there should be what? Minus sign. Now I'm not sure about this also, this value. So you do calculation and tell me what is the value of MD, that is bending moment at point D.
Correct, sir. It is correct.
Correct, sir.
Okay. See, it should not happen that I have solved all the problem and you are just listening. It doesn't happen with the problems. You have to solve these problems. Okay. You should have calculator with you. I'm talking with everybody. You should do the calculation. Otherwise, you will not have a practice of using calculator and you will not find the method also. Okay. Just concentrate on method by means of which you are solving problem. That answer, okay, I will put wrong answer also over there. So once you calculate this bending moment, then one can calculate the bending stress. So bending stress, one formula is given as M by I multiplied by Y, because sigma B by Y is equal to M by I, where M is the bending moment, I is the moment of inertia, and Y is the distance of that neutral layer from the uppermost layer. Okay. In this case, Y will become this diameter by 2, and here also this diameter by 2, that is 20 divided by 2 and 15 divided by 2. Now it can be written as M by Z, where Z is the what? Which moment of inertia? Section moment of inertia. Is it right? Okay. Where Z is nothing but pi by 32 d raised to 3. Because when we are going to put value of Y as a d by 2 and I as a pi by 30, pi by 4, pi by 64 d raised to 4 for the circular section. Okay. So this pi by 30, 64 d raised to 4, and this d will get cancelled and value of Z will come as a pi by 32 dq. Now bending stress, while we are going to calculate at point C where the force is acting, it will be bending moment divided by so this is divided, that is m suffix c divided by z suffix c, that is movement at point C divided by section is inertia at point C. So it will be 175.5 into 10 raised to 3, which is the bending moment at point C, divided by its section modulus, that is pi by 32, it is 32 is here, d cube, d is 20 in this case, so 20 cube. So what value you are going to get for this bending moment, sorry, stress at point B, bending stress at point C. Here we have written it as a sigma B suffix C. What value of stress you are getting?
Yes, sir. Same.
Is it right? That 223.45?
Yes, sir. Yes, sir.
Okay. Okay. So while we have calculated this bending moment at point C, now we have to calculate bending moment at point D. Now, while we are going to calculate bending moment at point D, we have taken this RA multiplied by 250 minus 2 into 10 raised to 3 minus 120. Okay. So likewise, we can calculate bending stress at point D. We have denoted it as a sigma B suffix D is equal to MD, that is bending moment at point D, divided by section modulus at point D. Okay. So this MD divided by ZD. Now ZD, while we are going to calculate, we are going to consider this lower diameter, that is 50. Okay. So it will be 97, that is the bending moment which is acting at point C, into 10 raised to 3 into 15 cube divided by pi, sorry, pi, again we have to take that this side. It is right, divided by pi by 32. Okay. So here also it is right. No. So what value you are going to get for that? Now it is 97.5 into 10 raised to 3 divided by 15 cube into pi divided by 32. What value you are going to get for sigma B? Can anybody tell? Do calculation and give me answer.
294.
294.25.
294. 294 point
25.
how much? 25.
Yes,
25
sir.
Newton per millimeter square. Okay. Now which stress you will consider for the calculation? Which reverse the stress you will consider? Whether it's the stress which is at point C or stress at point D. Now stress which is generated at point B is also reversed stress. Stress which is generated at point D is also reversed stress. But which value you will take for the calculation, further calculation? Hello? Can anybody answer?
Maximum value.
Maximum value, and that is 294.25. Okay. So we'll consider this is a repetitive stress which is acting at point D. Okay. Is becoming positive and negative, that is tensile and compressive. Now while we are going to consider this loop of stress, so the maximum value of the repetitive stress is going to become positive and negative. So starting from this point, let us consider reaching to this. So what will be sigma max in this case? As it is repetitive, that's why this will be the cycle. Now this value we are going to consider as a maximum stress, and that will be to one side tensile and to other side compressive. And minimum stress which is acting is the compressive stress, that is sigma max minus sigma max. So sigma max is nothing but from 0 to its maximum value to the one side, and 0 to its maximum value to the other side, that is tensile side and compressive side. Okay. So while we are going to calculate sigma mean will become 0 because it is sigma mean is equal to maximum stress. Okay. Minus will become plus. Okay. And this minimum stress. Okay. And divided by 2. So mean stress here is 0 because it is completely reversed the stress. And average value of stress, that is sigma average or amplitude we are going to call it as. Okay. That amplitude will be this much value. And this value already we have calculated. The average or amplitude, not average actually. I will say it as a amplitude only. So this amplitude, and this amplitude will be equal to 294.2 Newton per millimeter square. Now this same amplitude will be to the other side. One can measure it to the other side also. So to the other side also this amplitude will be the same. Now these three values we require: maximum stress, minimum stress, mean stress, and amplitude of that stress to go for the further calculation to calculate endurance limit. Now, actually endurance limit by calculation or by stress or by that Morse experiment has not given anywhere in the problem statement. That's why we are going to use standard endurance limit formulae. And that standard endurance limit formulae is, that is sigma suffix E dash is 0.5 of its ultimate tensile stress. Okay, for the ductile material, this is the point that in previous lecture we have seen various formulas by means of which we have calculated it. Okay, roughly from design data book which we can take. Now this formula should be by heart to you. It will not given anywhere in the statement. So this E dash is calculated as 0.5 into 1200, and it is 600 megapascal, that is nothing but 600 Newton per millimeter square. Now from this design data book, okay, this PSG is a actually publisher, and it is called as PSG design data book. From this design data book, further calculations are done, and in that case already we have given the graph as well as formulae by means of which we have calculated these various factors. See, this is the graph from which we can calculate the notch sensitivity and notch radius, which will give us idea of KF. Now, how the load factor is considered, how the size factor is considered. Now, this is the table from which we are going to get surface finish factor. Likewise, this table already I have told you that from design data book or from the Shigley's book it has been taken. Likewise, the actual tables or graphs will be produced to you at the time of problem solving. Okay, in exam actually. Otherwise, that values will be given to you. by means of which we have to calculate the that Ka, Kb, Kc. Are you getting me? So don't bother about that. But the value of or this formula will not be given to you. You should know it. So this endurance limit is calculated from the ultimate tensile stress, and that is 0.5 SUT. So we have calculated it. Now for calculating Ka, now can anybody remember what the Ka is? Hello? Are you remembering what the Ka is? Is surface finish factor. Okay, and that surface finish factor we have taken as 0.75. Okay, it is related to the SUT, and from graph we have taken that surface finish factor. Now Kb for that table is provided. Now what the Kb is actually? Kb is size factor. From that size we know that how to take the factor. So now you don't bother about all this, how I have selected it. Okay, हे जे मी इथं फक्त दाखवतोय Ka is equal to 0.75, Kb is equal to 0.85. मग ऍक्च्युअल प्रॉब्लेम सोडवताना तुम्ही असं बाय हार्ट करून लिहायचं का? तर तुम्हाला ज्यावेळेला एक्झाम मध्ये हा प्रॉब्लेम येईल त्यावेळेला तुम्हाला एकतर ते ग्राफ दिले जातील, टेबल दिला जाईल त्या प्रॉब्लेम स्टेटमेंटच्या खाली किंवा क्वेश्चन पेपरच्या शेवटी. ओके, सो व्हेन दिला जाईल त्यावेळेला यू हॅव टू सॉल्व दॅट प्रॉब्लेम, किंवा त्या स्टेटमेंटच्या खाली तिथे व्हॅल्यू ऑफ के दिली जाईल, व्हॅल्यू ऑफ केबी दिली जाईल. कन्सिडर के इज इक्वल 0.75, केबी इज इक्वल 0.85 असं दिलं जाईल. दोन्हीपैकी एक काहीतरी दिलं जाईल. ओके, so don't bother about that values. Now we have to calculate Kc. Kc is the reliability factor, and this formula you have to by heart, by means of which we are going to calculate the Kc. Okay, now if the reliability factor is given, otherwise table for that reliability factor will introduce to you. Let's see in the table. There it is. In previous slide it is there. Yes, on here it is surface finish and size factor. If you are not knowing that factor, you have to calculate by means of this formula. ही formula तुम्हाला पाठ करायला लागेल. Okay, and load factor already we have considered. Temperature factor and fatigue stress concentration, where the reliability factor is. For reliability factor also, such type of table will be produced. Okay, so we are going to take the reliability factor into account. Kc for 99% reliability. Just we have to calculate Kf. You know that Kf is equal to 1 plus notch sensitivity into bracket Kp minus 1. What the Kp is here? Hello? Kt काय indicate करते? Theoretical stress concentration factor. Right? Am I audible? Nobody is giving any answer.
Yes, sir.
So it is theoretical stress concentration factor, by means of which we can calculate the actual or fatigue stress concentration factor. So this Kf, which we can calculate as 1.4, because Kf is equal to 1 plus 0.9 into 1.44, the concentration factor. Okay, that we can select from the graph, previous graph which I have shown. or this value will be given in the problem statement. Okay, and Q also you have to select from the graph, or you have to take that value from problem statement. ह्या दोन व्हॅल्यू प्रॉब्लेम स्टेटमेंट मध्ये दिल्या जातील किंवा ग्राफ तुम्हाला दिला जाईल क्वेश्चन पेपरच्या पाठीमागच्या साईडला किंवा त्या प्रॉब्लेमच्या खाली. ओके, hence you can calculate kf, and once you do all this calculation we know that SE is equal to KA plus KB, or KA into KB into KC into KF multiplied by endurance limit, and that is KE dash, that is equal to 600. If you are going to do this calculation, you will get the actual or fatigue endurance limit, that is SE. Any doubt? Hello?
हॅलो सर,
बोला.
केटी कसं फाइंड केलं सांगा की.
KT.
हा.
This KT is calculated from diameter, bigger diameter divided by smaller diameter, high ratio. Okay, आणि radius of that curvature divided by small diameter. ह्या दोन व्हॅल्यू दिल्या तर एक ग्राफ दाखवला होता मी तुम्हाला. हा ग्राफ. ओके, त्या ग्राफ वरून ती व्हॅल्यू सिलेक्ट करायची आता. नॉच सेन्सिटिव्हिटी क्यू किती आहे? नॉच सेन्सिटिव्हिटी 21 नंबरची स्लाइड आहे. नॉच सेन्सिटिव्हिटी क्यू इज 0.9. Okay, then .9 आहे नॉच सेन्सिटिव्हिटी इथं कुठेतरी आहे, आणि रेडियस ऑफ दॅट नॉच, तर इथली रेडियस दिलेली आहे 2 मिलीमीटर. 2 मिलीमीटर आहे इथे, तर 2 आणि 0.9 इथं कुठेतरी तो फॅक्टर येणार आहे. ओके, हा रिलायबिलिटी फॅक्टर. आता ह्याच्यात जी व्हॅल्यू दिलेली आहे त्याच्यानुसार आपल्याला वी हॅव टू कॅल्क्युलेट दॅट थेरॉटिकल स्ट्रेस कॉन्सन्ट्रेशन फॅक्टर. ह्या दोन्हीच्या मध्ये जर बसत असेल, ह्या रेड लाईट, या दोन ज्या रेड लाईन आहेत त्याच्यामध्ये, ही जी हे रेड लाईन आहेत ते के टीचे. ओके, त्याच्या व्हॅल्यू दिलेल्या असतात. अशीच तुम्हाला डायग्राम एकतर पेपरच्या शेवटी दिली जाईल किंवा त्या के टीची व्हॅल्यू तुम्हाला प्रॉब्लेम स्टेटमेंट मध्ये दिली जाईल. हा, आणि त्याच्यावरून आपण केटीची व्हॅल्यू काढू शकतो.
Q0.9 कसं ठरवलं?
हा, त्यासाठी पण एक ग्राफ आहे. आता Q0.9 हाऊ वी आर गोइंग टू सिलेक्ट. हा जो ग्राफ आहे त्या ग्राफ मध्ये दिसतोय का बघूया. H/R जर 3 पेक्षा कमी असेल, हा डाटा आहे त्यासाठी. Q जर रेडियस एवढी असेल, ठीक आहे. त्यासाठी पण डिझाईन डाटा बुक मधला ग्राफ आहे जो नॉच सेन्सिटिव्हिटी इंडिकेट करतो. तो मी ग्राफ पुढच्या लेक्चरला ह्याच्यात दाखवतो, डिझाईन डाटा मधला कॉपी करून. आय विल टेक इट फॉर द ऑन द स्लाइड.